Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to look at using the method of completing the square to solve quadratic equations. In the last video, we looked at solving quadratic equations by taking the square root, by isolating the square term and taking the square root. But that only works if b is equal to 0. In other words, you don't have an x term. So if you have ax squared plus c equals 0, the square root method is a nice quick way of solving your quadratic equation. Then we also looked at using factoring as a method to solve your quadratic equation, but it only works if ax squared plus bx plus c is factorable, and it's probably only going to be a method that you use if you're comfortable and confident with your factoring skills. And not all quadratic equations are going to be factorable. Most won't be. So today we're going to look at a method called completing the square. It works on all types of quadratic equations. If b doesn't equal 0 and if it's not factorable, then we can look at this method. So I'm going to explain it through an example. My first example is actually one that I could solve by factoring, and it would be very quick and easy. The factors are x plus 7 and x minus 1. Gives me x squared minus 1x plus 7x gives me 6x minus 7. So we know that I'll have a solution if this factor is equal to 0, in which case x is equal to negative 7, or if x minus 1 is equal to 0, where x is equal to 1. So that one I can factor, but I'm going to show you completing the square on this example. We know what the answers are, and I'll show you how this method will get the same result. So completing the square means that you want a trinomial on the one side of the equation that's a perfect square. And I'm going to show you how to get that. First of all, you're going to move your constant to the other side. So we're going to add a 7 to both sides. Then, to make this a perfect square, we look at our middle term, we look at our b coefficient, and we divide it by 2, and we square it. So that's going to be 3 squared, which is 9. If I add a 9 to this side, I've created a perfect square. If I add a 9 to one side of the equation, I have to add a 9 to the other side. When you take half of that coefficient and square it and add it, you've created a perfect square, and that square will be x plus this value. So x plus 3, the whole thing squared. So when I multiply this out, x plus 3 times x plus 3, we'll get x squared plus 3x plus 3x plus 9. So this 3 gets doubled, and this is 3 squared. So that will always be true. If your coefficient here is a 1, you take half of that and square it, have that expression, that will be a perfect square. So 7 plus 9 is 16. Now to solve this, I'm going to take the square root. So the square root will be positive or negative. Square root of 16. So x plus 3 will equal the positive or negative square root of 16, which is 4. So x will equal negative 3 plus or minus 4. I just subtracted a 3 from both sides. So I'll have x equals negative 3 plus 4, which is 1. Or x will equal negative 3 minus 4, which is negative 7. So we obtained the same result, certainly a lot lengthier, but you might be required to use the method of completing the square to solve your quadratic equations. This isn't the easiest or the fastest method. but this is how it works. Let's do a few more examples. In this example, we have t squared minus 10t equals 8. So you want that constant over to the other side anyway. You just want your t squared term and your t term together, and any constants you're going to move to the other side. We want to make this a perfect square. So in order to do that, we take this coefficient for your t, divide it by 2, and square it. So that's going to be negative 5 squared, which is 25. So I want to add 25 to this expression to make it a perfect square. And if I do it to this side, I need to add it to this side as well. Now this is a perfect square, and I can write it as t minus 5 squared, because when we double that minus 5 we get negative 10, and when we square the negative 5 we get 25. So that doing this process will always give you a term that makes that a perfect square. That's equal to 33. Now we take the square root of both sides. Now I add a 5 to both sides. And there are my two solutions, 5 plus root 33, 5 minus root 33. Unless you're applying the quadratic formula to a special type of problem where the value means something, I would leave it as an exact value rather than using my calculator to get an approximate decimal value. So I would leave my answer as that and move on to the next question. I want to do an example now where we have a coefficient other than 1 for our x squared term. When that happens, you just right away just divide through by this coefficient so that we get a coefficient of 1. So we're going to divide everything by 2. When I divide this term by 2, I'll get x squared, minus 2 divided by 2 is 1, so minus x, minus 5 divided by 2 equals 0 divided by anything is still 0. Now we're going to move our constant term to the other side by adding 5/2 to both sides, and then we still do our same process. We take this coefficient, our b coefficient, which is negative 1, we divide by 2, and we square it. When we do that, we're going to get positive 1/4. And if I add it to one side, I need to add it to the other side. Now this trinomial is a perfect square, and the factors will be x minus whatever's inside this bracket, 1/2 squared. So we can try this. If you don't believe me. So x squared minus 1/2 x minus 1/2 x gives me minus 1x. Negative 1/2 times negative 1/2 is positive 1/4. And we need a common denominator here to add these. So this will be 10/4 plus 1/4, which is 11/4. Now we take the square root. So it's going to be the positive or negative square root of 11/4. Something that we can do with radicals is when you have a radical and it's a fraction, we can break that up. So we take the square root of the numerator over the square root of the denominator, because that allows me to simplify this to square root of 11 over 2. Now we're going to add a 1/2 to both sides to solve for x. So it'll be 1/2 plus or minus square root of 11 over 2. Because we have a common denominator here, we could combine these and write it as 1 plus or minus square root of 11 over 2. You could leave it in this form as well. Usually when you have fractions, especially when they have a common denominator, it's usually best to combine those so you just have one fraction. But it's a bit of a personal preference, and it's a bit of what's expected of you by your teacher. If you're expected to use completing the square as a technique for solving quadratic equations, follow the way I did these examples. and practice them on the questions that you have. If it's not something you're asked to do specifically, you probably aren't going to use this method. You're probably going to go into quadratic formula, which I'll cover in the next video.